Uh,
Okay, now you should also hear me from home, right? Yeah, but I was, yeah, I muted the device. Yeah, I was just saying that we will move to the third exercise, and that I made a minor mistake in the second exercise while I was solving it, but in the solution. Okay. So, third exercise. As I was saying, I will try to explain something about the thesis, master thesis of Nigora that ended up with a scientific paper in July. And it is about green steel production in Europe, so assessing the carbon footprint and market implication, meaning prices of European steel according to whether new technologies penetrates the market. So that's the overall idea. And you should also download the Excel file that I uploaded where you find the table, the starting point of the exercise, so we will start on that. And yeah, basically we used, again, a macroeconomic database that from the next module also the professor will tell you more about, which is called Exaiobase. I will propose a very aggregated version of this database, but if you want, in the supplementary material of the paper, you find the Zenodo repository with all the code and see. And maybe not now, but for the project work, you can have an idea. If you know something about Python, I don't know. Okay, yeah, but I strongly invite you to learn a bit of Python because we use it. We use only Python in our group. But in general, I think it's the trend. So most of researchers are moving to Python now for this kind of applications. Some economists using input-output are still using R or MATLAB, but most of industrial ecologists are moving to Python, are actually already using Python. So if you want to leave this field, I mean life cycle assessment, industrial ecology, policy analysis using these tools, I strongly encourage you to do a Python course, even on YouTube, to learn the basics. Like there are tons of easy courses. Yeah, but anyway. So this table, let's see the table. Okay. So this is the table. I guess you can't see very well, but okay. Let's see. It's a two-region table. We already dealt with the multi-regional tables in the previous ENSON, so you should be more acquainted with that. So there are two regions, Europe and rest of the world, again. In the full Exaiobase model, there are like 48 regions. So Europe is not just one region, but there are all the 27 member states plus others. Okay, and of course there are not just 4 products. There are 200 more or less. Okay, so these are an aggregated version. So we have 4 products: goods, services, steel, and electricity, with different unit of measures as well. So goods are in megatons, services are billion euros, steel is in, again, million tons, and electricity in terajoule. And then there are, I made some arrangements to this table so you can see that there is a difference between the rest of the world and Europe. So it's possible to define some technologies just for one of the regions. In the end, there are just, it's like having a certain number of industries, and dependently on where they are. So if it's in Europe or rest of the world, it's the same. So I added this green steel making because in our analysis we just focused on green steel making in Europe. So in the rest of the world, we just have average steel making, while in Europe, we distinguish between two technologies. So a traditional way and new ways. In the paper, there are more than one, but still, just to let you understand and simplify, we can just use one average green steel making. And you see there are some empty cells, and I also want you to note that these, the technology doesn't have unit of measures. I guess you already understand why. But if you see, for example, I don't know, services produce what? Produce goods and services. But goods is measured in million tons, and services is measured in billion euros. So basically, in these kind of physical models, when you have hybrid units, you can't actually provide the unit of measures for the technologies if they have heterogeneous products. So yeah, that's why you don't find units here. But of course, the single cells have units of measure. So you can say that these are million tons per output of the service technology, and so on. So there are some empty cells that we will start by filling those, and not only on the supply side, but also on the use side. Actually, it's the green steel making that is not characterized for the moment. Another difference between the previous exercise is that we are starting from coefficients. So we are starting from small letters, so from small u and d. So these are expressed per unit of output of each technology, so these consumptions. And then we have also the final demand, which is, again, okay, I use the scientific notation because actually they're not so deep. Okay, so this is the final demand. But first, we need to fill the table with the characterization of the green steel making technology. So we know that to produce 1 ton of green steel, actually I think it's 1 million ton. Okay, probably it's my mistake. 1 million ton of green steel will require 300 terajoules of electricity from Europe and 5 from the rest of the world. Then we need 0.12, again, I guess, million tons of domestic goods and 0.4 million tons of imported goods. 50% plus 50% of value-added factors. This is with respect to the traditional technology, so the steel making technology. And then all the other inputs are assumed equal to the traditional. Then we have the new emission factors, and we also know that currently no green steel is produced. Okay, so how to implement these numbers in the table? I don't know, maybe I can move to the. Let's start by the use matrix, and you can tell me one number one by one. Number. So here we know. Let's start from the electricity. So we know 300 terajoule from Europe and 5 from the rest of the world. So I guess that you. Can you tell me where I should put 305? 300 terajoule and 5 terajoule?
Not here because it is coefficient.
Yeah, but they are expressed per unit of green steel. So they are, so these data are in coefficients. I just missed, this is megaton, and also these are megatons, I guess. Okay. So, to produce 1 unit of green steel, I need 300 terajoules from Europe. So this is electricity from Europe. And plus other 5 from the rest of the world. So this is green steel in Europe that consumes 300 electricity, so 300 terajoule of electricity from Europe, and 5 from the rest of the world. This is clear, guys? So how to read this? Okay. Then we have 0.12 million tons of domestic goods and 0.4 million tons of imported goods. So the same ratio, so we go here to the goods, and we will need 0.12 of domestic ones, so domestic means from Europe, and 0.4 from the rest of the world. Then what? Then we know. Okay, other inputs are the same as traditional steel making. So these are actually equal to these. Okay. And then we know that we need 50% more of value-added factors with respect to traditional steel making. So this would be the coefficient of the traditional steel making times 1.5. Okay, they are very small numbers, but they are not zero. And then we know that emissions are capped to 0.3 million tons per million tons. Yeah, okay. So in the traditional steel making, we have 0.75, 76 million tons per million ton of steel. And here we have 0.3. Okay. So we did all the consumption side, so the use side. And then we know that there is no green steel making at the moment. So on the supply side, what do you expect? So of course, let's say that the green steel making doesn't provide anything else than steel. So these are zeros. So this row will just tells us what green steel making is providing in terms of any product. Okay, so if it's zero, it doesn't provide it. Okay. By the way, we are using which assumption, in your opinion, now to fill this matrix? Industry-based. Why? Someone said industry-based. Yeah, you're right. But actually, no. The question was, let's say, we have a rectangular matrix as the last time. So we have more technologies than products, if you notice. So we have 9 technologies and 8 products. Therefore, we can't use the product-based assumption because we can't invert a matrix, a non-square matrix. So that's why I put D, yes. But that's the reason. Okay. So if no green steel making is produced, what should I put here in these 2 cells? So it means this is D is the market share matrix. So here we are saying that only steel in Europe, this column here, is provided just by traditional steel making, and therefore there is no other production from the green steel making. Okay? Yeah, this is our starting point. we are assuming that no green steel making, actually probably it's also like this in the reality, or let's say there are negligible amounts of steel produced in innovative ways today with respect to the total. So that's our starting point also in the article. Okay. So let's go back to the presentation. Okay, so we should start by calculating the price and the greenhouse gas footprints for the European steel products. And we also want to compare these with the other steel from the rest of the world. So, footprints or prices. Okay, let's also call every sorry, I'm reading a question from the chat. Why 1 million ton of traditional steel? You refer to these numbers? I think so. It's not 1 million ton, it's like saying 100% of steel is produced by traditional steel making. So this is a market share. So they are coefficients. Okay? Okay, so price and GHG footprints. I guess you already know how to calculate the footprints. So we need basically RE. Okay. So I can give you 2 minutes to do so, to calculate it. Maybe someone could just tell me the formula so that you can go on first. So I equal to
inverse of the diagram x multiplied by the training multiplication.
Yeah, so it's R.
Inverse the diagram x, but we don't get x.
Yeah. So should be like R D W, right? Okay, the short version. Let's say R D W. To calculate W, we need x. Right. Let's start by calculating x first. And to calculate x, we also need something else first. So x would be actually q, and then x. So q would be w times y, but y we need a vector, so it's y dot. Y dot would be the sum of y. So when you have a known vectoral final demand, you need to transform it into a vector first. Okay? So you need w times y dot, and w, you can put it here for the moment, equals to I minus, in the industry-based assumption, x. I minus y d inverse, of course. So it's inverse of I minus y. So M inverse and mult. How much products we have? 8. How many? Minus. Sorry, M unit. M unit 8 minus M mult of U times D. Okay, so we have our Leontief matrix, and so that we can calculate Q by saying M mult W times Y dot. Okay. Are you with me, guys?
No, not just not.
So Q equals to W times Y dot. Okay. D is equal to, sorry, X equal to D times Q. Okay. So it's M mult of D times Q. Okay, so we have our production vectors. We have that, actually we didn't need X, so I just realized, but we needed just W here, so, but we will need it later, so let's calculate it. So we have 3 multiplication for RE. So we have R times another multiplication, and mult of D times W. Oops. Oops. What's happening? Let me check why I have this. No, sorry. It's not a mistake, but I just placed the matrix in the wrong place, because actually we expect what do we expect as a dimension of our E? Like the size of our E. It's okay. We need these two, of course, on the rows, but actually it's on the columns we have the products, right? So it should be below these columns. So I actually asked for 1 columns more, which is not there. So let's repeat it. So the formula was correct. It was, I just selected 1 extra column that there's not. Okay. So we want to see the price and the footprint of European steel versus the one of the rest of the world. So we need these 2 columns. So these 2 columns here. Let's see. And so let's say that we want to change the unit of measures to euros per ton. Okay. So the unit of measures of these two numbers, which is what is the unit of measures of these 2 numbers? So This is 0.0015.
Euros is
billion euros. Billion euros per megaton, right? So if we want euros per ton, what do we need to do? We should multiply by 1,000, right? Sort of. Is it so? Yeah. Okay, so yeah, it should be correct. So this is the price of European steel, right? So I do the same for the rest of the world steel. Oops. It's okay. Okay, so this is the price in the two regions, and so you notice already that in Europe, even without green steel making, we have a higher price. Okay, so which is how much? Okay, let's calculate it afterward. So let's also do the same for carbon footprints. So let's say that we have million tons per million tons, which is let's say ton per ton. And in this case, we don't have to convert anything. So it's 1.6 ton of steel, so ton of greenhouse gases per ton of steel. And here we have 1.87 ton of steel of CO2 or greenhouse gases per ton of steel.
So the unit to measure is a ton of CO2.
Yeah, actually it's megaton of greenhouse gas per megaton of steel. So ton over ton. Okay, or kilo over kilo.
Ton denominator is a ton of steel.
Yeah, this is ton G per ton of steel. Also the price, of course. So our starting point is this one. So we have more expensive steel than in the rest of the world, meaning us in Europe, but it's already less impactful, the environmental impact. Okay, this may be due to several factors, of course, but let's say probably our electricity sector is much less carbon intensive. We may also, okay, let's see if it's true. I see it as 0, but let's change this number to. Yeah, you see there is let's say this is a -5 to the -5 to the -4. So electricity in the rest of the world is much more carbon intensive, and therefore this may affect the carbon footprint of steel in the rest of the world, of course. But us, as Europe, are going to decarbonize steel sectors further. So let's move on with the exercise. Okay, so we just finished point B. Let's move to point C. Actually, it's an extra for you at home, this part. So this is a question that we won't see in the theory, but so we calculated the footprints, both of and prices, for products. So allocated the impact to the unit of delivered product, right? So what we just did is this one. But actually, if you think, there should be a the possibility also to allocate the impacts per unit of output of each technology. So instead of having a sort of weighted average footprint, so the idea would be we have multiple technologies like this one that compete in the market to produce the same product, right? So steel can be produced by different technologies. And the output, so this footprint, is, let's say, allocates or better, represents the impacts based on this market share, okay? So, for example, if I change to, of course, if I do all by green steel, this drops from 1.6 to 1, okay? What I changed here is the market share, so I reverse. Now it's all done by green steel making, okay? So the footprint was 1.6, so now it's 1.04. So this number here is based on that market share. But actually, the steel produced by each technology has its own footprint, okay? So this can be calculated by calculating the footprint of the output of each technology. So we are not covering that, but if you, I will give you the solution to get to that. But I invite you to reason on how to obtain these numbers. It's not difficult, but yeah. You can, maybe it can be useful also for the project for knowing that you can represent the footprint not just per unit of product, but also per unit of output of technology. That's actually what we did in the article as well. So we had multiple technologies and we analyzed the footprint of the steel produced by each of them to analyze which is the more carbon intensive and why. Well, in the article you will see also that the footprints, for example, can be even broken down, allocating it. So this number can be allocated also to the activity that is responsible to probably the Professor Rocco showed you that, no? No, I don't remember. Probably he told me that he would, but he didn't. Okay. But these numbers can be even broken down, allocating the responsibility of each share to the origin activity that is responsible for that impact. Okay, maybe I'm going too far, but yeah, there are some easy matrix multiplications and operations that you can do to get also those numbers.
What is the difference between a work loss as a group and the product based?
It's actually what I asked you to do is still industry-based technology.
Okay.
I think yeah. No, because the system operates in the same way in this case. So we don't we are not changing the D matrix. So the system always assumes then that when you are requiring 1 unit of steel, you activate a set of technologies that produce steel. But actually, you can calculate the footprint of each technology, not of steel as a product, but of each steel produced by each technology. Okay. So basically, you will end up having something here. So it's an environmental extension by technology as a dimension. Okay.
But steel is made only by two technologies. Steel making
yeah. Yeah, but these two can have different impacts. Okay. So imagine that you so up to now we are calculating the impact of the end of the supply chain of steel. So the end of the supply chain of steel is the delivered unit of steel. Okay? But Before that, there is a previous step, which is the production of steel by each of the technologies that produces steel. Then these two steels, so one from the traditional technology and the other from the steel making, then goes into a market and then is delivered as a, let's say, an average steel. Okay? You can get the impact of the previous step. So instead of having just the bottom line, you can have a previous step by calculating what is here, under here. Okay. I won't show you, but it will be in the solution of this exercise. Okay. Next point is assess the environmental. Maybe if we have time, I will go through that as well. Assess the environmental and price impact in the case 40% of used steel was manufactured as green steel. So we just did that basically, actually not 40%, but this would require. We didn't do everything because this would require investments. So in particular, we will need some million tons of goods, 2 million tons of goods, 3 gigajoule of electricity, 0.5 billion euros of services, and 0.1 million tons of steel of additional final demand. Okay? And assume these investments are domestic. So what is generally done in input-output models when you want to represent investments, you model that as an extra final demand to be delivered. So you need new machineries, you need new, I don't know, cement or whatever, goods, and therefore you basically need to build those and you allocate it in the final demand. So let's another sheet, so I don't waste the previous one. So what we need, okay, first of all, we want to analyze the case where 40% of green steel is green. So basically what we need to do is having this market share fixed. So we will have 0.4 green steel and 1 minus this, so 0.6 as traditional, okay? So this part is okay. And we can already see the impacts here. So actually, let's. I want also to have the previous one somewhere. So I copy paste this in the new sheet as values. Okay. So these are. So let's say that these are the baseline, and these are the green steel scenarios. Let's say that we have. So these are the values from before. Actually, let me change these back to the correct values. These are the values from before. So we had 1.6 ton of greenhouse gas per ton of steel. Now, by changing the market share to 40%, we have 1.4. Okay. But we also need to implement those investments. So these investments here. So we need 2 million tons of goods. Let's place them somewhere. So we need 2 million tons of goods. Okay, let's say investments. Okay, then we need what? 3 gigajoule of electricity, which is here. So this will be new data for us, basically. Okay. 0.5 billion euros of services and 0.1 million tons of steel. Okay, so 0.5 and 0.1. And we also say that these investments are domestic. Okay, is it clear, guys?
What does it mean, domestic?
Domestic means occur in Europe. Okay, so they are to be intended as domestic goods required to do these investments. Okay. You're right. Yeah, let me check the solution because I don't want to mess that. Okay. Let's say that they are 3 terajoules. Okay. Okay, so they are 3 terajoules. Okay, so
show the previous values between the tons and the results on the baseline.
what?
Okay. And you write 40%, right?
Yeah, see, yeah, here we have 40% of green steel, and here we have 0%. Okay. Okay, so what we changed our market share of steel. We need to change our final demand. So this will be our new final demand, which will be the old one plus investments. Okay, so and actually only this part is changing. So let's say, so because we are doing the investments in Europe from Europe. Okay, so that's why I'm changing only this side. Okay. Okay, so these will be, sorry? Is it clear? Okay. So let's say that this is the old one. So I'm taking it from here, on the previous file, sheet, plus these investments. Okay, they are not changing that much. But they will be a bit different from before. And the rest should be already done because we have our total final demand, which is calculated based on this new one. The Q, the X, whatever else should be already calculated. So we changed our D, we didn't change U. So W is already calculated based on the new D. So the new impact, so actually you see that those investments are not affecting practically anything. So the numbers were already, so they are pretty much the same as the ones we calculated before adding the investments. But for example, you can play with these numbers. Let's say we have, I don't know, 200 instead of 2 here. Let's see what it changes. More or less nothing.
We have to copy and paste values.
These ones, you mean? Yeah, these are taken from the other example.
Okay.
Yeah. So these others are new. But basically it doesn't affect. So this is just a refinement, but it doesn't affect that much. It depends on the numbers, of course. So let's calculate the delta, for example. So if we want to say So these are the deltas. So by doing so, by changing our system, we would have, let's say, let's focus on Europe, for example. We would have an increase in steel price of 1.4%, but a decrease of carbon footprint of 14.6%. Okay? So I'm strongly simplifying this part, guys. So the investment part would may require a model itself to be properly handled. But this is how approximately you could do also in the project work. So changing, let's say that the idea that I want to pass is that if you change how the system is structured, so how the system behaves, you probably would need new machines, new investments to make it happen. So, and how you model the make it happen thing in the final world. So you would need, okay, I need these new goods, these new services, blah, 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 from Europe, or you can even think from other countries. Yeah, and that's it. So this is how you probably will do in the project work as well. Okay. If I'm moving too fast from one place to another in the file, just tell me where I should focus. Yeah.
Why the greenhouse gases emission for the rest of the world changes?
Why? Let's see. It changes because probably, okay. It should be because European steel, so we are making European steel greener, cleaner. Okay, that's the idea. European steel probably is also used somewhere in the rest of the world. And so since the rest of the world doesn't change anything in its production structure, let's say, steel, so it keeps consuming steel, okay, in the same amounts, but this steel is somewhat greener, and so this is why also the carbon footprint of the rest of the world steel is also lowering a bit, of course by a negligible amount, but yeah, that's why. Okay, I think we can have some time also to defend the other part. So, but let's first finish. Okay, so this would be like a graphical representation of the changes. Okay, there would be another extra point here, but let's do it now because I think we have time to do so. So we want to know the impact. So another scenario. So let's say that now instead of moving to green steel, we want to offshore some production to the rest of the world. Actually, all the production. So let's say that from tomorrow, the European Union offshores all the steel production in the rest of the world. So, and of course, we will need to compare the results with the other scenarios. So what would you do to model this? So let's create another complete. And let's also copy this from here. the next point asks, okay, what is the impact in case European Union doesn't produce steel anymore, but it just asks rest of the world to produce steel also for Europe. So we relocate all the production to the rest of the world. So in terms of coefficients to be changed, what would you change?
The matrix and we do one to the rest of the world row.
You mean here?
Yeah.
Okay.
0.
Okay, this is one of the possibilities, but actually it doesn't work in this case because okay, you should know about the difference between Isard and Chenery-Moses tables, right? No? No, the professor didn't tell that. Okay, then let's discuss about that. So let's make a stupid model. So we have region 1. Okay, I expected him to do that, but let's say that we have just one product and we have two regions. Okay, so we have our D matrix. Okay, so I'm just representing a stupid model with just one product, one technology, but two regions. Okay, maybe I'm anticipating something, but yeah, actually you were correct in principle, but there are two kinds of tables of multi-regional input-output tables. So you have, so let's say that this is the U's and this is the D. Okay, you can have tables where the trades are allocated in here. So this is not just a market share, a domestic market share matrix, but it's a multi-regional market share matrix. So in this case, you will have numbers here. So not just in these parts, in these blocks, but also in the extra diagonal blocks. So this is what you were suggesting, right? So to change this part. Okay. But actually, and this is the what is called Chenery-Moses model. Okay, it's a kind of supply and use model, but where the trades are represented in this table here. Actually, in this Chenery-Moses model, you have, let's say, you have the trades here, and therefore, whatever you have in the use on the use side is just domestic. So you don't have anything here. So this is 0 and this is 0. That's why all the products consumed in a given region, so the supply side is already accounting for where it comes from. Okay, so here you have null extra diagonal blocks. What we are actually representing here in this exercise is what is called Isard model, where we have the opposite situation. But I'm quite sure that I'm anticipating something that Professor will tell you when it will he will get to the multi-regional tables. So in this case, we are representing just the domestic market shares in D. So we don't have any imports represented in here, but the imports are represented on the use side. Okay. So there are two alternative ways. They are more or less, yeah, representing the same thing. Here we have more details, actually. But from the modeling point of view, if you need to represent or to act, so implement some trade modeling, probably it's easier in this form. But okay, let's keep using these for now. So if we don't, so this should be zeros actually. These are zeros. It's not 0 point something, it's 0. Same here. Okay? And so if we have zeros here, actually it's a Isar model, so we don't have zeros here. Okay? And so if we want to move the domestic production to an imported production, so we don't want domestic production, which is this one. So in this case, we are saying this is domestic consumption of domestic goods, and this should be 0 in our scenario now. So, and where should we move those? Actually, not just these, but also these ones, and these ones. So this is the, if you sum all of these, you have the total production of steel by Europe, okay? And this should be 0 to our, according to our assumption. And therefore, what should we do?
These values to the rest of the world.
So these will be zeros.
Actually, we don't have to use this.
Sorry?
We have to add this number that you're going to relate to.
Yeah, exactly. So let me also come back to the this won't be y new, but will be y. So let's forget about the investments. Okay. So I copy the original y, so in the baseline. So this will be zeros. Okay. While these will be the previous ones. So these from the baseline plus the European ones, again from the baseline. And the same for the final demand. So is plus, okay. So that's it, I think, because, okay, no. Okay, I didn't change the market share, but actually you should expect that actually this doesn't change anything because we're not consuming any more European steel. So even if I don't change these, it shouldn't change anything. So here, okay, I have green steel, I have baseline. Let's calculate again. Okay, so this is a baseline minus green steel, or actually the opposite. So green steel minus baseline. But we want, okay, let's put it here. We want another scenario, which I would call offshore scenario. And again, so this is steel times 1000.
Can you go to the previous table with some numbers?
These ones? Yeah, what I did is I took the values from the original table. So and I sum these two lines here. So this one and this one from the very first table that we had. So the logic is I still need these amounts in total, and independently on where they come from. So I just allocate what I used from Europe to US. There's a question? In this scenario, we neglect that. So, okay, there could be, but we neglect.
Probably we can imagine that we can avoid to invest if domestically, if we decided to go to give everything.
Yeah. Of course, we can think. Okay, let's ask steel from the rest of the world. They will need some investments to address our demand, to fulfill our demand. Okay, of course we can put some extras here, extra final demand here, sorry, or whatever it will be. But yeah, for now I'm neglecting it. But you can play with the numbers, of course, so you can see how the model behaves in different conditions. So we have our new scenario. Let's calculate the delta also for this. Here, it will be offshore minus baseline. Okay, so in this case, we will have, I'm comparing these two. So before we had an increase in, let's say, we're not doing things right. No, okay, sorry. This actually changed. So I was saying before that how it's manufactured, so how the steel is manufactured in Europe doesn't change. Actually, it does change because here I'm looking at the carbon footprint independently on the final demand. So actually, even if here I'm not consuming any steel, the specific carbon footprint will actually be affected by this market share. Yeah, but this is specific to the unit, to the delivered unit of final demand. Even if I don't, this is independent of whether I'm consuming or not. If I calculate the big RE, this will of course be, this won't be affected by this, okay? Because I would multiply by 0, so this won't be affected. So let's move to the baseline also here in the market share. So what I'm getting here is that I have a lower price in this case. Zoom a bit. So I have a lower price because the rest of the world still is cheaper. And I have a slight increase in carbon footprint. Okay? Because the rest of the world still is more carbon intensive. However, the way the European economy works makes it not so more carbon intensive as it is in the rest of the world. Okay, so that's the idea. So even if the difference in carbon footprints of European and rest of the world steel, it's huge. Still, I'm consuming electricity from my power plants that are less carbon intensive, and so there are other effects that mitigate the carbon footprint of the steel that I'm importing. I see some confused faces.
Can you explain for the last time what is the meaning of that? We have to change one and the other zero. Because you really convinced me that we can.
Yeah, but this is
don't care about it, the market share, and then.
yeah, but this is in the way this matrix is calculated. So this depends by D.
Yes, it's true.
And so if I have a different D, it's actually it makes a difference. So if I move from to here, this matrix doesn't know if I'm delivering this product or not. It just says if I have to deliver that product, this is its impact. Okay? Because I'm producing it in this way. But if I'm not, let's move to the baseline case. So this is the impact. Okay? Okay, so the last point, what is the maximum market share of green steel that allows to have a price increase of domestic steel lower than 1%? Okay, there are some assumptions. So, to use the baseline model as a starting point and to neglect investments again. So, if we need to start from the baseline, let's copy the baseline again. So, move. So this okay. 20F. Okay, if I want to see to know which is the maximum market share of green steel, of course I will need optimization or a goal-seek at least. So I would need to add some constraints to my model. And actually, and therefore I need to maximize this number in the end. So the amount of green steel in the market share. And so I will express the other market share as 1 minus this one. Okay, let's just add those in red. And I also want the price increase to be lower than 1% as a constraint. So I'm having these. Not sure I want. Okay. Okay, let's. This is the baseline. Let's also have. Second. Okay, so this is my baseline, this is my optimal, let's say. Okay. Okay, so these are numbers taken from before. These are the new numbers calculated in the optimal solution. Of course, they are the same as now. And I want to calculate the delta as before. So this is the delta percentage as optimal minus baseline over baseline. Of course, it's 0 over baseline or probably.
You divide by 1.01. Yeah, and will divide by 1.01.
No, I want to constrain this number here. So let's say if I have if I'm changing the market share here, let's say I'm putting 0.4, these lead to an increase in price of 1.4%. Okay, I want these to be lower than 1%. This number. So let's put it somewhere. So this is delta price max. Let's call it like that. And so if I open my solver, I will need to maximize what? The market share of green steel by changing maximize by changing itself. So still the green steel market share, and I add the constraints that this must be lower than this. Okay, so this 1.4 should be lower than this one. So if I solve, I get, it's working. So I got 0.28 as a maximum market share. So this delta is 1%. And if I want, and I will have a carbon footprint reducing by 11.6% at the cost of a 1% increase in price. Sorry?
How to write S31 optimal.
Okay. This is exactly as before. So I took the footprint of steel in Europe, the footprint of steel in the rest of the world, and the price and footprints of steel in Europe and the rest of the world. And the delta is the relative difference between the two.
What we have to change in the
So the optimization is, I put as a objective and as a variable the market share of green steel. Of course, the objective is to maximize that. You can do it also with the goal seek, I think, in this case. Yeah, but yeah, you can change these in order that these minus these is 0. Okay, should work. Okay. Okay, I think we can spend some time also to this part here. Actually, I want to instead of spending time on how to get to the technology footprints, so the footprint specific to the output of each technology, I will tell you like something that blew my mind when I discovered that some years ago. That basically, if you think this framework, so the supply use framework, could be a sort of a specific case of a normal input output framework. So, for example, if I what is it? This. Guys, everything is everything clear from what we did now? So from point F.
That's a little problem with this one.
Okay, so it's it's market share maxed, changing the market share of green steel, and then you impose the delta to be lower than 1%. Delta price of your. But of course, this is just an example, guys. It's so you can play with the model as you wish. So. But what actually blew my mind when I discovered that actually was discovered in 2012, well, yeah, 2012, from 2 brilliant scholars. Is it fine? Everything okay? But no problem. You can play with that later. So, since I want you to also to discover this feature here. So, okay, what I was going to tell you is that if you think the supply use table is actually a specific case of a normal input-output framework, if you think. So let's say that actually we don't distinguish between U and D, but we actually have just one big Z matrix. So does it make sense to have these as a Z matrix? Why not? So we have industries, sectors, whatever. We have industry sectors. So from the mathematical point of view, it doesn't change anything if I have a Z matrix like this, or if I split between market share matrix and use matrix. So I can also add zeros here, so my Y matrix is this one. My Y dot would be this one. My Q, and of course I will need the Leontief matrix, which is, as in the input-output framework, will be calculated as W equal to inverse of I minus Z instead of U times D. So if I do the inverse of mu of 8 plus 9, 17 minus Z. This is my W matrix. If you see, we can also realize that this is correct, because if you check this part, this part should be exactly equal to what we calculated before. So 1.77, 0.065. If we move back, it's exactly these numbers here. So we are just isolating one part of the whole Leontief matrix. But yeah, from the mathematical point of view, we can deal with the supply use table exactly as it was an input-output framework. Okay? And yeah, this is also how our software Mario works. So the calculations in Mario are exactly dealt with this in this way. So even if I have a supply use table, I just took the whole thing together because it's actually easier to handle few operators than multiple operators, at least from the computational time, probably not. But when we started building the framework, we didn't thought about that. Okay, but then we can calculate x. This time is x both by product and technologies, and so we use mmult w and ytol. And also these numbers should be exactly equal to those we calculated before. And okay, guys, if at the exam we ask you about supply and use framework, don't answer with these formulas here, because we want you to know. Okay, if we ask for what is the formula of the Leontief inverse matrix in a supply and use framework, use inverse of I minus yd. This may be useful also to answer the questions. This question here. So actually, if you think of calculating the footprint now, in this case, you will get something which is this size. So both products and technologies. And actually, one part will be the answer to the question. There is a way to get just this part here with the supply and use table. You will see in the solution. But yeah, this was just a trick that I wanted to show, because when I discovered that, it blew my mind. Okay. I think we're over, guys. If you have any questions, doubts, we can, or if you want to repeat some of the steps. No?
Extra.
Yeah.
Like on Tuesday and Friday, that's like.
No, we are at the conference both on Thursday and Friday. Both myself and Professor. Okay, yeah. Thursday and Friday there will be no lecture, guys. So next lecture will be next Monday. Yeah. Yeah, with Rocco, yes. Okay, guys. So if there are no questions, I think we can stop.